Hello, my friend. Welcome to this quiet corner of the universe. Now we drift through the cosmos to explore our galactic home. 101 quiet truths about the Milky Way, each one a whisper from the vast spiral that holds us. Close your eyes and let these cosmic facts wash over you like gentle waves of starlight. Fact 1. The Milky Way contains between 100 and 400 billion stars. Imagine trying to count them all. If you could count one star every second, without pause, without rest, it would take you over 3,000 years just to reach 100 billion. And still, that might only be half the galaxy's population. Each point of light in the night sky represents not just one star, but millions, billions more, hidden behind the veil of distance and dust. Fact 2. Our galaxy spans roughly 100,000 to 120,000 light years across. To put this in perspective, light from the far edge of the galaxy began its journey toward us before humans learned to speak. Before we painted in caves, before we discovered fire, photons were already traveling through space, carrying stories from distant stellar nurseries. The galaxy is not just large in space, but vast in time. Fact 3. The Milky Way is only about 1,000 light years thick at most. Despite its enormous width, our galaxy is surprisingly thin, like a cosmic pancake spinning in the darkness. If you could shrink the Milky Way to the size of a dinner plate, it would be no thicker than a sheet of paper. We live in this delicate plane, surrounded by the gentle glow of 100 billion suns, arranged in gossamer layers. Fact 4. We are located about 26,000 to 28,000 light years from the galactic center, not in the crowded downtown of stars near the core, nor lost in the sparse suburbs of the outer rim. We inhabit a quiet neighborhood, the Orion Arm, where star formation proceeds at a gentle pace and catastrophic events are blessedly rare. This placement may have been crucial for life's emergence on Earth. Fact 5. The Milky Way rotates, but not like a solid wheel. In the inner regions, stars complete their orbits quickly, racing around the galactic center in just a few million years. Further out, where we live, the pace slows dramatically. Our sun takes 225 to 250 million years to complete one galactic orbit. This differential rotation creates the spiral pattern we see, like cream being stirred slowly into cosmic coffee. Fact 6. Our solar system moves through the galaxy at approximately 828,000 kilometers per hour. That's 230 kilometers every second, fast enough to circle Earth in just over 6 minutes. Yet space is so vast that this incredible speed feels like stillness. The stars appear fixed in their patterns, unchanged from generation to generation, though everything is actually in constant, silent motion. Fact 7. In all of Earth's history, our solar system has completed only 20 galactic orbits. When the first complex cells appeared on Earth, we were in an entirely different part of the galaxy. When the dinosaurs walked, the stars above looked different. The last time we were exactly where we are now in our galactic orbit, the supercontinent Pangaea was just beginning to break apart. Fact 8. The Milky Way is a barred spiral galaxy, classified as type SBBC. The SB indicates a prominent bar structure crossing the galactic center, like a cosmic bridge of stars. The BC describes how tightly wound our spiral arms are. From far away, we would appear as an elegant spiral with arms that sweep outward in graceful curves, painted in the blue light of young stars. Fact 9. On the clearest, darkest night, you can see only about 0.0003% of the Milky Way stars with your naked eye. Perhaps 2,000 to 3,000 stars become visible under perfect conditions, a tiny fraction of our galaxy's population. Most stars are hidden by dust, dimmed by distance, or simply too faint for human vision. We live surrounded by an ocean of light, yet see only the nearest drops. Fact 10. The Milky Way belongs to a group of over 80 galaxies, called the Local Group. Our cosmic neighborhood spans about 10 million light years and includes the Great Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller companions. We are not alone in space, but part of a gravitationally bound family of galaxies, all slowly dancing through the expanding universe. Fact 11. The galaxy has been growing through cosmic cannibalism for billions of years. Our Milky Way has consumed countless smaller galaxies, absorbing their stars and leaving only faint streams as evidence of these ancient mergers. Right now, the Sagittarius dwarf galaxy is being slowly torn apart its stars are being scattered across our sky like cosmic breadcrumbs, marking the path of a dying galaxy. Fact 12. The oldest stars in the Milky Way are nearly as old as the universe itself. In the galactic halo, ancient red giants burn with light that began when the cosmos was young and met. Some of these stellar elders are over 13 billion years old, formed when the Milky Way was still assembling from smaller pieces, still learning how to become the spiral we know today. Fact 13. Our galaxy contains roughly 1 billion Earth-mass planets. This is not counting gas giants, ice worlds, or rocky planets much larger or smaller than Earth, just worlds approximately the same size as our home. Scattered throughout the spiral arms, some orbit red dwarf stars that will burn 4 trillions of years. Others circle sun-like stars in systems that may harbor their own stories of life and consciousness. Fact 14. The Milky Way recycles its matter continuously. Stars are born from gas clouds, live their luminous lives, and die in spectacular explosions that scatter enriched material back into space. This cosmic recycling has been ongoing for billions of years. Every atom in your body, except hydrogen, was forged in the nuclear furnace of a star that died long before our solar system formed. You are literally made of stardust. Fact 15. From the surface of Earth, we see our galaxy ajan as a band of light crossing the sky. Because we live within the galactic plane, we cannot see the Milky Way's true spiral structure with our eyes. Instead, we observe it from within, like standing in a vast forest and looking along the line of trees. The pale streak we call the Milky Way is our inside view of home, compressed into a single luminous arc spanning from horizon to horizon. The galaxy that holds us is more than a collection of stars. It is a dynamic, evolving structure with a past, present, and future. It breathes with stellar birth and death, grows through cosmic mergers, and spins with a rhythm that marks time on scales we can barely comprehend. We are not merely observers of this cosmic dance, but participants carried along on currents of gravity and time through the endless night. As these first 15 truths settle into your awareness, feel yourself floating in the gentle embrace of galactic space. You are home here, in this quiet corner of an ancient spiral, surrounded by the soft glow of distant suns and the whispered stories they tell across the darkness. Now we drift deeper into the galaxy's structure, exploring the elegant architecture that shapes our cosmic home. Like examining a vast cathedral built from light and gravity, we discover how the Milky Way organizes itself across the immensity of space. Fact 16. The Milky Way has between 2 and 4 major spiral arms, but astronomers still debate the exact number. From our position deep within the galactic disk, it's remarkably difficult to map our own galaxy's structure. Dust clouds obscure distant regions, and perspective plays tricks with our vision. Recent surveys suggest we may live in a galaxy with just 2 major arms, with additional spurs and fragments creating a more complex pattern than early astronomers imagined. Fact 17. Our solar system resides in a minor structure called the Orion spur or local arm. This is neither a major spiral arm nor empty space, but something in between a branch or spur extending from the larger Sagittarius arm. It's about 10,000 light-years long and 3,500 light-years wide. We live in galactic suburbia, removed from both the crowded inner city and the sparse countryside, in a region that may be ideal for the slow development of complex life. Fact 18. The galactic halo extends far beyond the visible disk, possibly reaching 200,000 light-years in diameter. This vast spherical region surrounds our galaxy like an invisible shroud, containing ancient stars, globular clusters, and enormous quantities of dark matter. The halo is sparsely populated compared to the disk, but it may contain more total mass than all the spiral arms combined. It is the galaxy's hidden foundation. Fact 19. Spiral arms are not fixed structures but density waves moving through the galactic disk. Stars and gas don't stay in the arms permanently. Instead, they flow into these regions of higher density, become compressed, form new stars that light up the spiral pattern, then drift out again as the wave passes by. It's like a cosmic traffic jam that creates the illusion of permanent structure while everything continuously flows and changes. Fact 20. The Milky Way's disk is warped, bending upward on one side and downward on the other. This subtle warp becomes more pronounced toward the outer edges, creating a gentle S-curve that spans the galaxy's diameter. The distortion may be caused by gravitational interactions with the large and small Magellanic Clouds, or by the uneven distribution of dark matter. Our galaxy is not perfectly flat, but gently twisted, like a spinning record that has been slightly bent. Fact 21. The galactic center hosts a supermassive black hole called Sagittarius A*, with a mass of about 4 million suns. This dark monster sits at the heart of our galaxy, invisible to our eyes, but detectable through its gravitational influence on nearby stars. We've watched stars whip around it at incredible speeds, their orbits tracing the shape of invisible gravity. Sometimes material falls toward this black hole, heating up and flaring in X-rays before vanishing forever beyond the event horizon. Fact 22. A thick bar of stars crosses the galactic center, spanning about 27,000 light-years from end to end. This central bar rotates slowly, completing one turn every few 100 million years. Its gravitational influence shapes the inner spiral arms and helps funnel gas toward the galactic core. Many spiral galaxies have such bars, and they appear to be important in galactic evolution, stirring the central regions and feeding the supermassive black holes that lurk at their hearts. Fact 23. The Milky Way contains over 150 globular clusters scattered through its halo. These are among the oldest objects in our galaxy spheres, containing hundreds of thousands of ancient stars, some over 12 billion years old. They orbit the galactic center on long, slow paths that take them far above and below the main disk, like cosmic time capsules. They preserve information about conditions in the early universe when heavy elements were scarce and star formation followed different rules. Fact 24. The galaxy's thick disk lies above and below the thin disk where we live. While the thin disk is where most star formation occurs today, the thick disk contains older stars with different chemical compositions and more random orbital motions. These stars tell the story of a more chaotic era in the galaxy's past, possibly shaped by early mergers and interactions that stirred the galactic structure before it settled into its current form. Fact 25. Vast stellar streams crisscross the galaxy, remnants of smaller galaxies that were torn apart by tidal forces. These faint ribbons of stars can stretch for hundreds of thousands of light wrapped around our galaxy like ghostly scarves. Each stream tells the story of a cosmic collision, a smaller galaxy that wandered too close and was slowly unraveled. Its stars scattered but still following the gravitational memory of their disrupted home. Fact 26. The interstellar medium, the gas and dust between stars, makes up about 10 to 15% of the galaxy's visible matter. This thin material fills the space between stars, organized into cold molecular clouds where stars are born, warm neutral regions, and hot ionized bubbles carved out by stellar explosions, though nearly empty by Earth standards. The interstellar medium is the raw material from which future generations of stars and planets will form. Fact 27. Giant molecular clouds, the largest structures in the galaxy, can span several hundred light years and contain hundreds of thousands of solar masses of material. These cold, dark regions are stellar nurseries where gravity slowly gathers gas into clumps that eventually collapse to form new stars. The Orion Nebula, visible to the naked eye as a fuzzy star in the constellation Orion, is a small star-forming region within one of these vast molecular clouds. Fact 28. The galactic plane contains most of the galaxy's dust, which blocks visible light but glows in infrared. This cosmic dust is made of tiny grains of carbon, silicon, and ice, created in the atmospheres of dying stars and scattered by stellar explosions. While it obscures our view in visible light, infrared telescopes can peer through the dust to reveal hidden star formation and map the galaxy's true structure. What looks like darkness often conceals the brightest stellar nurseries. Fact 29. Hot gas in the galactic halo shines in X, revealing a corona of million-degree plasma surrounding the Milky Way. This hot halo may contain as much mass as all the stars in the disk combined, though it's so diffuse that it's nearly invisible. The gas is heated by supernova explosions and stellar winds that carry energy far from the galactic plane, creating a vast atmosphere around our galaxy that extends into intergalactic space. Fact 30. The Milky Way's magnetic field threads through the galaxy, influencing how cosmic rays travel and how star formation proceeds. Though incredibly weak by terrestrial standards, this magnetic field organizes itself into complex patterns that align with spiral arms, loop through the halo, and help shape the interstellar medium. Radio telescopes can trace these invisible field lines by observing how they affect the polarization of radio waves from distant sources. The architecture of our galaxy reveals itself slowly, like a vast structure emerging from morning mist. Each component of spiral arms, the central bar, the surrounding halo plays a role in the cosmic symphony that has been playing for billions of years. We are not just passengers in this structure, but products of it, formed from elements created in stellar furnaces, gathered from molecular clouds, and shaped by the same gravitational forces that organize the galaxy itself. As you rest in this knowledge, imagine yourself floating through these galactic spaces, drifting between spiral arms where new stars are kindling to life, passing through the thin interstellar medium where ancient light carries stories across vast distances. You are part of this architecture, a conscious pattern in the cosmic web, awakening within the galaxy that gave birth to you. We turn now toward the galactic center, that crowded region where ancient forces shaped the heart of our cosmic home. Here, in the deepest core of the Milky Way, darkness and light dance together in ways that challenge our understanding of space and time. Fact 31. The galactic center is hidden from our view by thick lanes of dust that absorb visible light. When we look toward the constellation Sagittarius, we see only the nearest layers of stars and gas. Behind this cosmic curtain lies the true heart of the galaxy, a region so dense with stars that if we lived there, our night sky would be filled with thousands of stars brighter than Venus, casting shadows on planetary surfaces and making darkness nearly impossible. Fact 32. At radio wave, the galactic center glows with the signature of Sagittarius A*, our galaxy's central black hole. This radio source, no bigger than Mercury's orbit, marks the location of an object whose gravity is so strong that light itself cannot escape once it crosses the event horizon. We cannot see the black hole directly, but we observe its influence on everything around it, like detecting a massive invisible dancer by watching the movements of their partners. Fact 33. Stars near the galactic center orbit at tremendous speeds, some reaching thousands of kilometers per second. One star, designated as 2, has been observed completing an elliptical orbit around Sagittarius A* in just 16 years. At its closest approach, this star travels at nearly 3%, the speed of light, fast enough to circle Earth in just over 4 seconds. These observations provided direct proof that general relativity correctly describes the behavior of space and time in extreme gravitational fields. Fact 34. The central black hole is surprisingly quiet for its enormous mass. Most supermassive black holes in other galaxies actively consume material and shine brilliantly as quasars are active galactic nuclei. But Sagittarius A* is dormant, consuming very little material. Occasionally, we detect brief flares as small amounts of gas fall inward. But for now, the heart of our galaxy sleeps quietly, like a slumbering giant surrounded by a whirlwind of stars. Fact 35. The galactic center region contains the highest concentration of stars in the Milky Way. Within just a few light years of the black hole, millions of stars crowd together in a density that's millions of times greater than in our solar neighborhood. These stars influence each other gravitationally, sometimes colliding or merging, creating unusual stellar objects that can't form anywhere else in the galaxy. Fact 36. Massive star clusters near the galactic center produce some of the most luminous stars known. The arches and quintuplet clusters contain dozens of hydrogen stars so massive and bright that they burn through their nuclear fuel in just a few million years. These stellar titans are so rare that they exist almost exclusively in the extreme environment near the galactic core, where dense molecular clouds can collapse to form the most massive stars possible. Fact 37. The galactic center shows evidence of past periods of much greater activity. Giant structures called the Fermi bubbles extend 25,000 light-years above and below the galactic plane, glowing in gamma rays. These enormous lobes may be the remnants of a massive outburst from Sagittarius A* that occurred several million years ago, when our ancestors were just beginning to walk upright on the African savanna. Fact 38. Hypervelocity stars are occasionally ejected from the galactic center at speeds of thousands of kilometers per second. These stellar exiles are thought to be the remnants of binary star systems that ventured too close to the central black hole. When a binary pair encounters Sagittarius A*, one star may be captured while the other is flung outward at incredible speed, fast enough to escape the galaxy entirely and journey into intergalactic space. Fact 39. The central bar structure rotates independently of the spiral arms, completing one rotation about every 200 million years. This bar acts like a cosmic stirring rod, reorganizing the flow of gas and stars in the inner galaxy. Its gravitational influence creates resonances that shape the spiral pattern and may help transport material toward the central black hole, feeding it during periods of greater activity. Fact 40. Young, massive stars shouldn't be able to form so close to the galactic center, yet they exist in abundance. The extreme tidal forces near Sagittarius A* should tear apart the dense gas clouds needed for star formation. The presence of young stars within light years of the black hole suggests they either formed elsewhere and migrated inward, or that star formation in extreme gravitational environments follows different rules than we understand. Fact 41. The galactic center hosts a population of ancient, metal-rich stars that tell the story of the galaxy's early chemical evolution. These stars formed when the central region was actively creating and recycling heavy elements through rapid star formation and supernova explosions. Their chemical signatures revealed that the galactic center was once a stellar nursery, far more active than the relatively peaceful spiral arms where we live. Fact 42. Strange objects called G-clouds orbit near the galactic center. They appear to be gas clouds but behave like stars. These mysterious objects have baffled astronomers because they show characteristics of both diffuse gas clouds and compact stellar objects. Some theories suggest they may be stars surrounded by dusty envelopes or the remnants of stellar collisions shaped by the extreme environment at the galaxy's heart. Fact 43. The innermost region of the galaxy may contain a secondary massive object, possibly another large black hole. Gravitational interactions and stellar orbits near the center show perturbations that might indicate the presence of additional massive invisible objects. If confirmed, this would suggest that the galactic center harbors not just one supermassive black hole, but possibly a system of massive dark objects that formed during the galaxy's earliest epochs. Fact 44. X-ray observations reveal hot gas threading through the central regions, heated to millions of degrees by stellar winds and supernova explosions. This hot interstellar medium creates a glowing atmosphere around the galactic core, visible only to space-based X-ray telescopes. The gas forms filaments and bubbles that trace the paths of ancient stellar explosions and the ongoing cycle of stellar death and birth. Fact 45. The galactic center may have experienced multiple episodes of black hole feeding throughout cosmic history. Layers of structure in the surrounding gas and unusual stellar populations suggest that Sagittarius A has gone through cycles of activity and dormancy, sometimes consuming large amounts of material and shining as a bright quasar, then settling into quiet periods that last for millions of years. The heart of our galaxy is a place of extremes, where the familiar rules of stellar physics are pushed to their limits. Here, in this crowded, radiation-soaked region, the Milky Way's most dramatic stories unfold stories of gravitational violence, stellar collisions, and the hungry darkness at the center of it all. Yet even this apparent chaos follows deeper patterns, shaped by the same forces that organize the gentle spiral arms, where we make our home. From our quiet suburban location in the Orion Spur, the galactic center seems impossibly distant and alien, but its influence reaches throughout the galaxy, organizing the great spiral pattern and ultimately creating the stable environment that allowed our solar system to form and life to. We are connected to that distant heart by invisible threads of gravity and galactic rotation, participants in a story that began billions of years ago in the galaxy's violent youth. Now we drift among the stars themselves, those brilliant points of nuclear fire that illuminate the galaxy's structure and drive its evolution. Each star tells a story of birth, life, and death, and together they weave the luminous tapestry we call the Milky Way. Fact 46. The Milky Way forms about 1 to 3 new stars every year, a rate that has been declining over cosmic time. In the galaxy's youth, star formation proceeded much more rapidly, creating the ancient populations we see in globular clusters and the galactic halo. Today's star formation is gentler, sustained by the slow collapse of molecular clouds and the recycling of material from previous stellar generations. We live in a mature galaxy that has settled into a steady, contemplative pace of stellar creation. Fact 47. Most stars in the galaxy are red dwarfs, small stars with masses less than half that of our sun. These dim, long-lived stars burn hydrogen so slowly that they can shine for trillions of years, far longer than the current age of the universe. Red dwarfs are so faint that none are visible to the naked eye, despite being the most numerous type of star. They represent the galaxy's patient majority, quiet embers that will outlive all other stellar types. Fact 48. The most massive stars in the galaxy live fast and die young, burning through their nuclear fuel in just a few million years. These blue giants and hypergiants shine with the luminosity of hundreds of thousands of suns, but their intense radiation pressure and rapid nuclear burning doom them to brief, spectacular lives. When they die in supernova explosions, they scatter heavy elements throughout the galaxy and leave behind neutron stars or black holes as their final monuments. Fact 49. Our sun is a fairly typical middle-aged star, about 4.6 billion years old and roughly halfway through its main sequence lifetime. It belongs to a stellar population called Population I, which formed from gas that had already been enriched with heavy elements by previous generations of stars. This chemical enrichment was crucial for the formation of rocky planets and, ultimately, life itself. We orbit a second or third generation star, built from the recycled ashes of ancient suns. Fact 50. The galaxy contains three distinct stellar populations that formed at different epochs. Population 3 stars were the first to form after the Big Bang, made almost entirely of hydrogen and helium. None of these primordial giants survive today, but their supernova explosions enriched the early universe with the first heavy elements. Population 2 stars formed next, with small amounts of metals, and populate the galactic halo and globular clusters. Population I stars like our Sun formed most recently from metal-enriched material in the galactic disk. Fact 51. Brown dwarfs, sometimes called failed stars, are scattered throughout the galaxy in numbers that may rival normal stars. These objects formed like stars from collapsing gas clouds, but never accumulated enough mass to sustain hydrogen fusion in their cores. They glow dimly from residual heat and deuterium burning, slowly cooling over billions of years. Brown dwarfs represent the galaxy's stellar embryos that never quite achieved the nuclear ignition that defines true stars. Fact 52. Binary and multiple star systems make up the majority of stellar systems in the galaxy. Single stars like our Sun are actually in the minority. Many stars share their lives with companions, orbiting each other in gravitational dances that can last for billions of years. These stellar relationships can dramatically affect stellar evolution, with material transferred between stars, orbits that decay over time, and sometimes catastrophic collisions that create exotic objects found nowhere else in the universe. Fact 53. White dwarf stars, the cooling remnants of Sun-like stars, will eventually become the galaxy's most common stellar corpses. When stars like our Sun exhaust their nuclear fuel, they shed their outer layers and leave behind hot, dense cores about the size of Earth but with the mass of the Sun. These white dwarfs cool slowly over tens of billions of years, gradually fading from white to yellow to red to brown, and finally becoming cold. Dark objects called black dwarfs, though the universe is not yet old enough for any black dwarfs to exist. Fact 54. Neutron stars, formed in supernova explosions, are the densest objects in the galaxy after black holes. These stellar remnants pack more mass than the Sun into a sphere, only about 20 kilometers across. A teaspoon of neutron-style material would weigh as much as Mount Everest. Some neutron stars spin hundreds of times per second while beaming radiation into space, creating the lighthouse-like signals we detect as pulsar's cosmic timepieces more precise than any human-built clock. Fact 55. The chemical elements that make life possible were forged in stellar cores and distributed by stellar deaths. Carbon, nitrogen, oxygen, iron, and dozens of other elements are created through nuclear fusion in the hearts of stars. When these stars die there through gentle mass loss or explosive supernova, they scatter their newly forged elements into space, where they become incorporated into the next generation of stars and planets. Every atom in your body, except for hydrogen, was created inside a star. Fact 56. Some stars have been ejected from the galaxy entirely, traveling through intergalactic space at speeds exceeding 1,000 kilometers per second. These hypervelocity stars were likely accelerated by gravitational encounters with the supermassive black hole at the galactic center, or by supernova explosions in binary systems. They are stellar refugees, carrying light and heat into the darkness between galaxies, never to return to their birthplace. Fact 57. Variable stars throughout the galaxy serve as cosmic lighthouses, helping astronomers measure distances and understand stellar Kified variables pulsate with periods directly related to their intrinsic brightness, making them valuable standard candles for measuring galactic distances. Our Lyrae stars serve a similar function for nearby stellar populations. These stellar lighthouses flash their coded messages across space, allowing us to map the galaxy's structure and understand its history. Fact 58. The galaxy's star formation rate varies dramatically between different regions. The spiral arms contain active stellar nurseries where massive, hot stars illuminate colorful nebulae. The galactic halo experiences virtually no star formation today, while the central bulge had its most active period billions of years ago. This spatial variation in star formation has created the galaxy's layered structure, with different regions dominated by stellar populations of different ages and compositions. Fact 59. Stellar streams. Thin trails of stars mark the disrupted remains of star clusters in small galaxies that have been torn apart by the galaxy's tidal forces. These streams can be traced across vast distances, wrapping around the galaxy like ghostly ribbons. They provide evidence of the Milky Way's ongoing growth through the accretion of smaller systems. And they help astronomers understand how galaxies like ours assembled over cosmic time. Fact 60. The Sun has completed fewer than 25 orbits around the galaxy during its entire 4.6 billion-year lifetime. Each galactic year lasts 225 to 250 million Earth years, meaning that many of the galaxy's long-term cycles occur on timescales far longer than individual stellar lifetimes. The last time our solar system was at its current position in the galaxy, the supercontinent Pangaea was just beginning to break apart, and dinosaurs had not yet evolved. Stellar lives and galactic rhythms march to very different drummers. The stars of the Milky Way are not merely points of light scattered through space, but participants in an ongoing cosmic story of birth, evolution, and renewal. From the faintest red dwarf that will outlive our sun by trillions of years, to the most massive supergiant that burns brilliantly for just a few million years. Each star contributes to the galaxy's chemical and structural evolution. They are the galaxy's inhabitants, its citizens, its memory keepers. We turn now to the invisible choreography that governs galactic motion, the dark matter, magnetic fields, and gravitational currents that shape how our galaxy moves through space and time. These are the hidden forces that make the cosmic dance possible. Fact 61, dark matter comprises about 85% of the Milky Way's total mass, yet we cannot see it directly. This mysterious substance reveals itself only through its gravitational effects, the way it bends light, influences stellar orbits, and holds the galaxy together. Without dark matter, the outer regions of the galactic disk would spin so fast that stars would be flung into intergalactic space. Something invisible and unknown provides the scaffolding that keeps our cosmic home intact. Fact 62. The galaxy's rotation curve defies what we would expect from visible matter alone. According to Newton's laws, stars farther from the galactic center should orbit more slowly, just as outer planets in our solar system take longer to complete their orbits around the sun. But in the Milky Way, stars maintain nearly constant speeds even at great distances from the center. This flat rotation curve is one of the strongest pieces of evidence for dark matter's existence. Fact 63. The Milky Way is surrounded by a vast halo of dark matter that extends far beyond the visible stars. This dark matter halo may reach 300,000 light years from the galactic center, 3 times wider than the stellar disk. Within this invisible cocoon, the familiar spiral galaxy we see is just the luminous tip of a much larger, unseen structure. We live inside a dark matter galaxy that happens to contain a bright spiral of stars and gas at its center. Fact 64. Magnetic fields thread through the galaxy, organizing the interstellar medium and influencing star formation. Though incredibly weak by Earth standards, these galactic magnetic fields extend across thousands of light years, shaping the paths of cosmic rays and the collapse of gas clouds. Radio telescopes can trace these invisible field lines by observing how they affect the polarization of radio waves, revealing a complex magnetic architecture woven throughout the galaxy. Fact 65. The sun oscillates up and down through the galactic plane as it orbits the galaxy, completing one vertical cycle every 60 to 70 million years. This gentle bobbing motion is caused by the gravitational pull of the galactic disk's mass. Currently, we are moving upward through the plane and will reach maximum height above it in about 15 million years before beginning to fall back down. Some scientists have speculated that these oscillations might influence long-term climate patterns or extinction events on Earth. Fact 66. Cosmic rays energy particles accelerated by supernova and other violent events constantly stream through the galaxy and through our body. These particles, mostly protons and atomic nuclei, travel at nearly the speed of light, carrying enormous energies across galactic distances. Earth's magnetic field and atmosphere protect us from most cosmic rays, but some reach the surface, occasionally causing errors in computer systems or contributing to the background radiation that surrounds us. Fact 67. The galaxy rotates differentially, with different parts spinning at different rates. The central bar rotates slowly, completing one turn every few hundred million years. The spiral arms pattern rotates at yet another speed, creating the density waves that trigger star formation. Our sun happens to orbit at nearly the same speed as the spiral pattern, keeping us in a relatively stable environment between major spiral arms for long periods of galactic time. Fact 68. Gravitational waves from distant cosmic collisions pass through the Milky Way, causing tiny ripples in space-time itself. When black holes spiral together and merge, or when neutron stars collide, they send out these waves at the speed of light. Though the distortions they cause are incredibly small, than 1,000th the width of a proton-sensitive instruments can now detect them, opening a new window into the violent events occurring throughout the universe. Fact 69. The local standard of rest defines how we measure stellar motions within the galaxy. This is the average motion of stars near the sun, providing a reference frame for understanding how individual stars move relative to the galaxy's overall rotation. Stars with unusual velocities, either much faster or slower than the local standard, often have interesting stories. They may be visitors from other parts of the galaxy, survivors of disrupted clusters, or members of stellar streams from ancient mergers. Fact 70. Galactic tides to differential, gravitational. Pull across extended objects can disrupt star clusters and satellite galaxies over long periods. Just as the moon's tidal force causes ocean tides on Earth, the Milky Way's immense mass creates tidal forces that can stretch and eventually tear apart smaller gravitationally bound systems. Many of these stellar streams we observe are the stretched out remains of globular clusters or dwarf galaxies that fell victim to these inexorable tidal forces. Fact 71. The galaxy's escape velocity varies with location, but near the solar system it's approximately 550 kilometers per second. This is the minimum speed an object needs to completely escape the Milky Way's gravitational pull. A few hypervelocity stars have achieved these speeds and are now traveling through intergalactic space. For comparison, Earth's escape velocity is only 11 kilometers per second. The galaxy's gravity well is far deeper than anything we experience on planetary scales. Fact 72. Dark matter particles may be colliding and annihilating in the galactic center, potentially producing gamma rays that could reveal their nature. Several experiments are searching for these signatures, hoping to directly detect dark matter interactions for the first time. The galactic center, with its high concentration of dark matter, represents one of our best chances to observe these elusive particles doing something other than just exerting gravitational force. Fact 73. The Milky Way's motion through space creates a dark matter wind as our solar system plows through the galactic halo. Earth-based experiments are trying to detect this wind by looking for seasonal variations in dark matter interaction rates. Since our planet's orbital motion around the sun should create slight changes in our velocity relative to the dark matter. Background. These experiments represent our most direct attempts to detect dark matter particles in laboratory settings. Fact 74. Magnetic field reversals may occur in the galaxy, similar to how Earth's magnetic field occasionally flips polarity. The galactic magnetic field is generated by the rotation of ionized gas and cosmic rays, and computer simulations suggest it could undergo large-scale reorganizations over millions of years. Such reversals might affect the galaxy's ability to retain gas and could influence star formation rates across the entire disk. Fact 75. The galaxy exists in a delicate gravitational balance between expansion and collapse. If dark matter were distributed differently, or if the galaxy rotated at a different rate, the delicate spiral structure might not exist. Too little rotation, and the galaxy would collapse into a ball of stars. Too much, and it would fly apart. The Milky Way represents a stable solution to the gravitational equations that govern how matter organizes itself on galactic scales. The invisible forces that govern our galaxy operate on scales and time scales that dwarf human experience. Dark matter provides the gravitational foundation. Magnetic fields organize the interstellar medium, and cosmic rays carry energy across vast distances. These hidden currents shape everything from the large-scale structure of spiral arms to the local environment, where stars and planets form. As you contemplate these stellar generations, imagine yourself drifting between the different populations past ancient halo stars that remember the galaxy's youth, through the active spiral arms where new stars are still being born, among the patient red dwarfs that will witness the galaxy's distant future. You are connected to all of them through the elements they created, the space they illuminate, and the gravitational forces that bind the galaxy together. We turn now to the invisible choreography that governs galactic motiony dark matter, magnetic fields, and gravitational currents that shape how our galaxy moves through space and time. These are the hidden forces that make the cosmic dance possible. Fact 61. Dark matter comprises about 85% of the Milky Way's total mass, yet we cannot see it directly. This mysterious substance reveals itself only through its gravitational effects, the way it bends light, influences stellar orbits, and holds the galaxy together. Without dark matter, the outer regions of the galactic disk would spin so fast that stars would be flung into intergalactic space. Something invisible and unknown provides the scaffolding that keeps our cosmic home intact. Fact 62. The galaxy's rotation curve defies what we would expect from visible matter alone. According to Newton's laws, stars farther from the galactic center should orbit more slowly, just as outer planets in our solar system take longer to complete their orbits around the sun. But in the Milky Way, stars maintain nearly constant speeds even at great distances from the center. This flat rotation curve is one of the strongest pieces of evidence for dark matter's existence. Fact 63. The Milky Way is surrounded by a vast halo of dark matter that extends far beyond the visible stars. This dark matter halo may reach 300,000 light-years from the galactic center, 3 times wider than the stellar disk. Within this invisible cocoon, the familiar spiral galaxy we see is just the luminous tip of a much larger, unseen structure. We live inside a dark matter galaxy that happens to contain a bright spiral of stars and gas at its center. Fact 64. Magnetic fields thread through the galaxy, organizing the interstellar medium and influencing star formation. Though incredibly weak by Earth standards, these galactic magnetic fields extend across thousands of light-years, shaping the paths of cosmic rays and the collapse of gas clouds. Radio telescopes can trace these invisible field lines by observing how they affect the polarization of radio waves, revealing a complex magnetic architecture woven throughout the galaxy. Fact 65. The Sun oscillates up and down through the galactic plane as it orbits the galaxy, completing one vertical cycle every 60 to 70 million years. This gentle bobbing motion is caused by the gravitational pull of the galactic disk's mass. Currently, we are moving upward through the plane and will reach maximum height above it in about 15 million years before beginning to fall back down. Some scientists have speculated that these oscillations might influence long-term climate patterns or extinction events on Earth. Fact 66. Cosmic rays, energy particles accelerated by supernova and other violent events, constantly stream through the galaxy and through our book. These particles, mostly protons and atomic nuclei, travel at nearly the speed of light, carrying enormous energies across galactic distances. Earth's magnetic field and atmosphere protect us from most cosmic rays, but some reach the surface, occasionally causing errors in computer systems or contributing to the background radiation that surrounds us. Fact 67. The galaxy rotates differentially, with different parts spinning at different rates. The central bar rotates slowly, completing one turn every few 100 million years. The spiral arms pattern rotates at yet another speed, creating the density waves that trigger star formation. Our Sun happens to orbit at nearly the same speed as the spiral pattern, keeping us in the relatively stable environment between major spiral arms for long periods of galactic time. Fact 68. Gravitational waves from distant cosmic collisions pass through the Milky Way, causing tiny ripples in space-time itself. When black holes spiral together and merge, or when neutron stars collide, they send out these waves at the speed of light. Though the distortions they cause are incredibly small, than a thousandth the width of a proton-sensitive instruments can now detect them, opening a new window into the violent events occurring throughout the universe. Fact 69. The local standard of rest defines how we measure stellar motions within the galaxy. This is the average motion of stars near the Sun, providing a reference frame for understanding how individual stars move relative to the galaxy's overall rotation. Stars with unusual velocities, either much faster or slower than the local standard, often have interesting stories. They may be visitors from other parts of the galaxy, survivors of disrupted clusters, or members of stellar streams from ancient mergers. Fact 70. Galactic tides, differential, gravitational. Pull across extended objects can disrupt star clusters and satellite galaxies over long periods. Just as the moon's tidal force causes ocean tides on Earth, the Milky Way's immense mass creates tidal forces that can stretch and eventually tear apart smaller gravitationally bound systems. Many of these stellar streams we observe are the stretched out remains of globular clusters or dwarf galaxies that fell victim to these inexorable tidal forces. Fact 71. The galaxy's escape velocity varies with location, but near the solar system it's approximately 550 kilometers per second. This is the minimum speed an object needs to completely escape the Milky Way's gravitational pull. A few hypervelocity stars have achieved these speeds and are now traveling through intergalactic space. For comparison, Earth's escape velocity is only 11 kilometers per second. The galaxy's gravity well is far deeper than anything we experience on planetary scales. Fact 72. Dark matter particles may be colliding and annihilating in the galactic center, potentially producing gamma rays that could reveal their nature. Several experiments are searching for these signatures, hoping to directly detect dark matter interactions for the first time. The galactic center, with its high concentration of dark matter, represents one of our best chances to observe these elusive particles doing something other than just exerting gravitational force. Fact 73. The Milky Way's motion through space creates a dark matter wind as our solar system plows through the galactic halo. Earth-based experiments are trying to detect this wind by looking for seasonal variations in dark matter interaction rates. Since our planet's orbital motion around the sun should create slight changes in our velocity relative to the dark matter. Background. These experiments represent our most direct attempts to detect dark matter particles in laboratory settings. Fact 74. Magnetic field reversals may occur in the galaxy. Similar to how Earth's magnetic field occasionally flips polarity, the galactic magnetic field is generated by the rotation of ionized gas and cosmic rays, and computer simulations suggest it could undergo large-scale reorganizations over millions of years. Such reversals might affect the galaxy's ability to retain gas and could influence star formation rates across the entire disk. Fact 75. The galaxy exists in a delicate gravitational balance between expansion and collapse. If dark matter were distributed differently, or if the galaxy rotated at a different rate, the delicate spiral structure might not exist. Too little rotation, and the galaxy would collapse into a ball of stars. Too much, and it would fly apart. The Milky Way represents a stable solution to the gravitational equations that govern how matter organizes itself on galactic scales. The invisible forces that govern our galaxy operate on scales and timescales that dwarf human experience. Dark matter provides the gravitational foundation. Magnetic fields organize the interstellar medium, and cosmic rays carry energy across vast distances. These hidden currents shape everything from the large-scale structure of spiral arms to the local environment, where stars and planets form. Now we turn to the galaxy's deep history, reading the ancient stories written in starlight and gravitational scars. Like archaeologists uncovering layers of civilization, astronomers piece together the Milky Way's past from the traces left behind by cosmic events that occurred billions of years ago. Fact 76. The Milky Way formed over 13 billion years ago through the gradual merger of smaller protogalactic fragments. In the early universe, matter was distributed more evenly, but tiny density fluctuations grew over time under the influence of gravity. Our galaxy began as a collection of dark matter halos that slowly accumulated gas and began forming the first stars. This process was not smooth or orderly, but chaotic, with many small galaxies merging and cannibalized to build the structure we inhabit today. Fact 77. The galaxy's oldest stars preserve chemical signatures from the universe's first stellar generations. In the galactic halo, astronomers have discovered stars with almost no heavy element sum containing less than 1/10,000th the iron content of our sun. These ancient suns formed from gas that had been enriched only by the very first supernova, carrying chemical fingerprints from when the universe was young and the process of element creation had barely begun. Fact 78. Major merger events have shaped the galaxy's structure throughout its history. The most significant recent event was the Gaian, which occurred 8 to 11 billion years ago when a dwarf galaxy with about 1/4 the mass of the Milky Way's stellar component was disrupted and absorbed. This collision heated the galactic disk, scattered stars into the halo, and may have triggered a burst of star formation that enriched the galaxy with heavy elements. Fact 79. Stellar streams crisscrossing the sky are the smoking guns of ancient galactic cannibalism. Each stream represents a smaller galaxy, or a star cluster, that was torn apart by tidal forces. Its stars stretched into long, curved ribbons that wrap around our galaxy. The Sagittarius stream, the longest known stellar stream, extends more than 360 degrees around the sky, marking the ongoing destruction of the Sagittarius dwarf galaxy that has been orbiting and slowly dissolving into the Milky Way. Fact 80. The galaxy's chemical evolution can be traced through stellar archaeology analyzing the elemental compositions of stars of different ages. The oldest stars contain almost pure hydrogen and helium, the products of Big Bang nucleosynthesis. Progressively younger stars show increasing amounts of carbon, oxygen, silicon, and iron, created by successive generations of stellar nucleosynthesis and distributed by supernova explosions. This gradual chemical enrichment made possible the formation of rocky planets and, eventually, life. Fact 81. The thick disk of the galaxy may have formed during a chaotic period of early mergers and violent star formation. Stars in the thick disk have different chemical compositions and kinematic properties compared to the thin disk where we live. They appear to be the survivors of a more turbulent era when the galaxy was still assembling, when supernova explosions and gravitational interactions stirred stellar orbits and heated the galactic disk to greater thickness. Fact 82. Globular clusters serve as fossil records of the conditions in the early galaxy. These ancient stellar cities contain hundreds of thousands of stars that form together from the same gas cloud, preserving information about the chemical composition and star formation processes from over 12 billion years ago. By studying globular clusters, astronomers can reconstruct what the young Milky Way was like before it settled into its current spiral structure. Facts 83. The galaxy has experienced multiple epochs of enhanced star formation, triggered by mergers and gas accretion events. Chemical evolution models suggest that star formation was not constant but occurred in bursts, with peaks corresponding to major merger events or the accretion of gas-rich dwarf galaxies. These starbursts enriched the interstellar medium with heavy elements and may have influenced the galaxy's overall structure and evolution. Fact 84. Evidence suggests the Milky Way's central bar formed relatively recently, possibly within the last few billion years. Computer simulations show that spiral galaxies can develop bars spontaneously as stellar orbits become unstable due to spiral density waves and gravitational interactions. The formation of our galaxy's central bar may have reorganized gas flows in the inner galaxy and influenced the evolution of the spiral arm pattern we see today. Fact 85. The local group of galaxies, including the Milky Way and Andromeda, is slowly falling toward the Virgo cluster under its gravitational influence. This motion, at about 630 kilometers per second, represents our galaxy's participation in even larger scale structure formation. We are not just part of a galaxy or even a galaxy group, but participants in the ongoing collapse and organization of matter on scales of hundreds of millions of light. Fact 86. Radioactive dating of the oldest stars suggests the galaxy began forming stars just a few 100 million years after the Big Bang. Some halo stars show evidence of having formed when the universe was only 500 million to 1 billion years old, making them among the most ancient objects we can observe. These stellar time capsules carry information from an epoch when the first galaxies were just beginning to coalesce from the cosmic web of dark matter and gas. Fact 87. The galaxy's spiral pattern may be a relatively recent development, with the dramatic spiral arms we see today possibly forming only within the last few billion years. Computer models suggest that spiral patterns can come and go in disk galaxies, triggered by interactions with satellite galaxies or instabilities in the stellar disk. The beautiful spiral structure that defines our galaxy may be a temporary phase in its long evolutionary story. Fact 88. Multiple stellar populations in globular clusters reveal complex formation histories that challenge our understanding of early galaxy assembly. Many globular clusters contain two or more distinct groups of stars with different chemical compositions, suggesting they experienced multiple episodes of star formation. This complexity indicates that even the oldest structures in our galaxy have rich, multi-layered histories that we are still working to understand. Fact 89. The Milky Way has likely captured and disrupted dozens of smaller galaxies throughout its history, but most of this evidence has been erased by time. Only the most recent mergers leave clear traces in the form of stellar streams and chemical signatures. Earlier accretion events have been mixed into the general stellar population, making it difficult to reconstruct the complete merger history that built our galaxy over cosmic time. Fact 90. Future archaeological studies using next-generation telescopes may reveal even more ancient merger events by detecting the faintest stellar streams and chemical anomalies in halo stars. Projects like the Vera Rubin Observatory and the Nancy Grace Roman Space Telescope will map stellar motions and compositions across the entire galaxy with unprecedented precision, potentially uncovering merger events that occurred over 10 billion years ago and revealing new chapters in the Milky Way's formation story. The galaxy we inhabit today is not the same one that existed billions of years ago. It has grown through countless mergers, evolved through episodes of intense star formation and quiet periods of gradual chemical enrichment. The Milky Way carries within its structure the memory of these ancient events and the chemical compositions of its oldest stars, in the orbital patterns of stellar streams, in the layered architecture of disk and halo. We conclude our cosmic journey with the deepest mysteries, the questions that remind us how much we still don't understand about our galactic home. These final facts illuminate not just what we know, but the vast territories of knowledge that remain to be explored. Fact 91. The nature of dark matter remains one of astronomy's greatest unsolved puzzles, despite comprising 85% of the galaxy's mass. We don't know if dark matter consists of exotic particles, primordial black holes, or something else entirely beyond our current physics. Experiments deep underground and in space continue searching for direct evidence of dark matter interactions, but the substance that holds our galaxy together remains stubbornly invisible to all our attempts to detect it directly. Fact 92. Fast radial bursts detected from beyond our galaxy may originate from magnetized neutron stars with magnetic fields trillions of times stronger than Earth's. Some of these mysterious millisecond flashes of radio energy have been traced to our own galaxy, suggesting that the Milky Way occasionally produces some of the most energetic radio signals in the universe. The exact mechanism that creates these bursts is still debated, representing a frontier in our understanding of extreme stellar physics. Fact 93. The galaxy may harbor intermediate mass black holes objects, more massive than stellar mass black holes but smaller than supermassive. These hypothetical objects, with masses between 100 and 100,000 suns, have been difficult to detect but may lurk in globular clusters or roam freely through the galactic disk. Finding and studying them could help astronomers understand how supermassive black holes like Sagittarius originally formed. Fact 94. Mysterious gamma ray sources scattered throughout the galaxy emit high-energy radiation through unknown processes. While many gamma ray sources have been identified with pulsars, supernova remnants, or binary star systems, a significant fraction remain unidentified. These unknown gamma ray emitters may represent new types of stellar objects or exotic physical processes that we have yet to understand. Fact 95. The galaxy's outermost regions may extend much farther than we currently know, possibly reaching halfway to the Andromeda Galaxy. Recent discoveries of distant stellar streams and halo stars suggest that the Milky Way's gravitational influence and faint stellar population may extend 300,000 light-years or more from the galactic center. We may be living in a much larger galaxy than we previously imagined. Fact 96. Primordial black holes formed in the early universe might make up some fraction of the galaxy's dark matter. These hypothetical objects, created from density fluctuations shortly after the Big Bang, could have masses ranging from asteroids to stars. If they exist in large numbers, they could help explain both dark matter and the origins of supermassive black holes, but detecting them remains an enormous challenge. Fact 97. The center of our galaxy may have experienced a quasar phase within the last 10 million years, when Sagittarius A* was actively consuming material and shining billions of times brighter than it does today. Evidence for this recent activity comes from the Fermi bubbles and reflected light from gas clouds that show signs of having been ionized by intense radiation from the galactic center. We may live in a galaxy that was recently much more active and violent than it appears today. Fact 98. Rogue planets worlds. Without parent stars may outnumber bound planets in the galaxy. These orphan worlds, ejected from their birth systems or formed in isolation, drift through interstellar space in permanent darkness. Recent estimates suggest there could be billions or even trillions of these nomad planets, invisible to our telescopes, but carrying with them the possibility of exotic forms of life, sustained by internal heat rather than starlight. Fact 99. The galaxy's magnetic field may play a crucial role in regulating star formation, but the exact mechanisms remain poorly understood. Magnetic pressure can both support gas clouds against gravitational collapse and help trigger star formation by concentrating material along field lines. The interplay between magnetism, turbulence, and gravity in the interstellar medium represents one of the most complex physical systems in the universe. Fact 100. Time dilation effects mean that clocks at different locations in the galaxy run at slightly different rates due to varying gravitational potential. A clock near the galactic center in the strong gravitational field of Sagittarius A* would run measurably slower than one in our solar neighborhood. These relativistic effects are tiny but real, meaning that time itself flows differently in different parts of our galaxy. Fact 101. We may never fully understand our galaxy because we can only observe it from one location within it. Future space missions might carry telescopes to different parts of the solar system, providing new perspectives, but we will always be embedded within the structure we're trying to study. The Milky Way will likely remain partially mysterious, its full three-dimensional structure and history forever filtered through our particular vantage point in space and time. These mysteries remind us that the galaxy is not just a collection of known objects following predictable laws, but a vast, dynamic system full of phenomena we have yet to understand. Each generation of astronomers discovers new puzzles even as they solve old ones. The Milky Way continues to surprise us, challenge our theories, and expand our sense of what's possible in the cosmos. As our journey through these 101 facts draws to a close, let yourself float in the vastness of all we have explored together, from the basic architecture of spiral arms and central bulge, through the violent processes that forge elements in stellar cores, to the invisible dark matter that provides the galaxy's gravitational foundation. We have traced the grand patterns that organize our cosmic home. You are part of this story. The calcium in your bones was created in the explosion of a massive star. The iron in your blood was forged in a stellar core under pressures and temperatures that dwarf anything on Earth. The oxygen you breathe was scattered into space by dying stars and gathered into the molecular cloud from which our solar system formed. You are not separate from the galaxy, but woven into its very fabric. A conscious arrangement of cosmic matter awakening to contemplate its own origins. The Milky Way continues its ancient rotation, carrying you and your world on a journey that began over 13 billion years ago and will continue for billions more. Stars are being born in stellar nurseries while others are dying in spectacular explosions. Dark matter streams invisibly through space, holding everything together with its gentle, persistent gravity. Somewhere in the spiral arms, other worlds may harbor their own forms of consciousness, their own observers looking up at the same galactic backdrop and wondering about their place in the cosmic order. Tonight, as you rest beneath this vast spiral of light, know that you are home in the deepest sense, not just on a planet or in a solar system, but within a galaxy that has been preparing for your existence across cosmic ages. The elements that compose you, the energy that flows through you, and the very space you occupy are all part of the Milky Way's ongoing story of creation and transformation. Sleep well in the knowledge that you are exactly where you belong, floating in the gentle embrace of 100 billion stars. Participants in the greatest story ever told, the slow, patient awakening of the universe to its own wonder and beauty. If you find yourself still awake, you might continue exploring the cosmos in the next chapter of our journey. But for now, let these cosmic truths carry you softly into dreams, filled with starlight and the infinite possibilities that await in the vast spiral.